Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be talking about GRE mathematics subject test, and this video is for inverse of a function, right? So this is part 1 pre-calculus, section 1 functions, and you have the part that is inverse of a function. Just a disclaimer, this is not the GRE general test, this is GRE mathematics subject test, right? Okay, so let's go ahead and get started. So before I define inverse of a function, I need to define few things which are very important. So as I said, that a function is a map, let's say from A to B. You can even say that the map is from X to Y. So when I say it's a map from A to B, there are different type of functions. So first type of functions are called injective functions. Now what are injective functions? So let's suppose you have a function f of A to B. An injective function would be where no two elements in A are mapped to the same element in B. So what are injective functions? Where no two elements in A are mapped to the same element in B. So are mapped to the same element in B. So graphically speaking, if let's say if x1 is not equal to x2, that would mean that f of x1 is not equal to f of x2. Right? So if you have, let's say these are all the A values and these are all the B values, you have only one value that is, so you can't have one X value corresponding to two different Y values. That's not possible. Every A value, no two elements in A are mapped to the same element in B. So they are mapped to different elements, right? So that is the case. So just an example that I would like to use here, an example would be, let's suppose if you have a function y is equal to x cube. Now how does y is equal to x cube look like? Y is equal to x cube looks something like this, right? So as you can see here clearly that there are no two x values which will have the same y value, isn't it? There's no two x values which will have the same y value, right? So in that case, that means I can clearly say that this function is injective. So there's kind of a horizontal line test. So if you draw a horizontal line, the graph will actually cut only one single point, right? So that means that the function is injective. On the other hand, let's suppose if I have y is equal to x squared, this is something which is not injective because y is equal to x squared looks like this. As you can clearly see that x is equal to -2 and x is equal to 2, they're both mapped to y is equal to 4. So again, if I draw a horizontal line, it's gonna cut the graph at 2 points, right? So if it cuts the graph at 2 points, that means it is not an injective function. So this is something which I call the horizontal line test. Right? So if the function has to be injective, it has to pass the horizontal line test, which means that if I draw any horizontal line, it will only cut the graph at least maximum 1 point. Now the next type of functions that you have are called surjective functions. Now what are surjective functions? Now surjective functions are, they're also called, onto functions. They're also called onto functions, right? So a surjective function is a function in which every element in B is the image of some element in A. It says that every element in B is the image of some element in A. So I mean to say that if you have B here and this has A here, every element here is covered, right? It has some image in A, right? So it has some image. Now, let's say, for example, y is equal to x cube. Again, how does y is equal to x cube looks like? Y is equal to x cube looks like this. So every y value is associated with the x value, right? So every y value is associated with the x value. So if I draw a line from here, it will cut the graph at 1 point. Right? So this is kind of a vertical line test. So a vertical line test tells you whether a particular function is surjective or not. right? While on the other hand, if I say y is equal to x square, so when I say y is equal to x square, this actually looks something like this. Okay, just forget about the vertical line test because I think it's irrelevant here. Okay, so y is equal to x cube. When I say y is equal to x cube, this looks something like this. You can clearly see that every y value is associated with some x value. Every y value has an image with at least one x value, right? On the other hand, when I say y is equal to x square, if you look at this particular y value, that is -4, right? And it's defined from all real numbers to all real numbers, then this will not be a surjective function because it's defined from all real numbers to real numbers. That means -4 is not going to be the part of, it's not going to be a surjective function, right? Because a -4 there is no mapped value for y is equal to -4 if it is defined from real numbers to real numbers. Let's say it's defined for only non-negative numbers, well then it is an onto function. Fine, so I hope you got that, guys. I hope you understood it. Now, what relationship does this have with inverse function, right? So now I'm actually going to introduce another type of function which is known as bijective function. Now, what is a bijective function? A bijective function is a function which is an injective function as well as it is a surjective function, which means that all values of a are mapped to values, which means there are no two values of a mapped to same value of b, and all values of b are mapped to some value in a value of a. So it's injective also and it is surjective also. Now what that means, that we can say that the function is completely mapped, and we can say that every value of x has a value of y. So this is what we say a function. A function is f of x is equal to y, and it is bijective. And if and only if a function is bijective, we can say that an inverse of the function exists, right? If and only if a function is bijective, that means inverse of a function exists. And inverse of a function only exists if it passes the horizontal line test and it also passes the vertical line test. So if it passes the horizontal line test and the vertical line test, then only we can say that the inverse of a function exists. So how do you denote the inverse of a function? So let's suppose if I say that f of x is equal to y, then the inverse of the function is going to be f inverse of y is equal to x. Understand, this is not an exponent, but this is just a denotion of an inverse of a function. Neither it is the reciprocal of the function. It is not the reciprocal of the function. This is how we denote the inverse of a function. Right? What input of y will you give to get the value of x? I'm just going to take a little example here. So that example is, let's say for example you have y is equal to x plus 3, right? So when I say y is equal to x plus 3, then y minus 3 is equal to x, right? Now I can substitute x, so I can always substitute x as f inverse of y. So this is the inverse of that function. So remember, we used to substitute y with f of x. Now what we can do is we can substitute x with f inverse of y. This is something that we can do all the time. I hope you got that, guys. I hope you understood this. Another few things that I want to say is that f inverse of f of x is going to be equal to x, and f inverse of f of y is going to be equal to y. You can actually cut the f's and say x is equal to x. You can cut the f's and you can say y is equal to y. That's one way of remembering it, but that's not the way it works. So that's actually a good way of remembering it. Now let's say for example, if I have a function, let's say y is equal to x square, right? So let's say this over here, it's a function. Now I want to find out whether an inverse of this function exists or not. So this is how this function looks like. So for an inverse to exist, it has to pass the horizontal line test and it has to pass the vertical line test. Now if I do a horizontal line test, you can clearly see that it's passing through 2 points. It has to pass through only 1 point. So if it's passing through 2 points, that means the inverse of a function does not exist. Okay, so that's there. Let's say, for example, if you have y is equal to x. So y is equal to x looks something like this, right? So it passes the horizontal line test as well, and it passes the vertical line test as well, which means the inverse of the function exists. Now, if the inverse of a function exists, how are you going to find the inverse of a function? So how do you find the inverse of a function? Well, there is a step-by-step process. First of all, make x as the subject. So what you do is you make x as the subject. So let's suppose if you have a function y is equal to x square plus 1, then you have to make x as the subject, right? So y minus 1 is equal to x square, right? And x is actually equal to plus or minus square root y minus 1. So this is what you do. You've made x as the subject. Now what you do is you replace x with y and y with x. So that means the inverse of this function is y is equal to plus or minus x minus 1. This is the inverse of this function. I don't know whether it exists or not. I haven't checked that, but this is the inverse of this function. Now to check whether this inverse is a function or not, you have to do the vertical line test or the horizontal line test. So I hope you understood what I was explaining here, guys. So this is what it is, right? So moving on to some questions, right? So I'm just going to summarize what I did here just so that you understand. So you have few types of functions. First type of function is your injective function. The second type of function is surjective function, which is also an onto function. This is also called a one-to-one function. When I say one-to-one function, that means every value of a no two values of a are associated with a single value of b. When I say an onto function, I mean to say every value in b has an image in a, and combining both of them we get bijective functions, right? And if and only if a function is bijective, that means if and only if a function is one-to-one and onto, then only the inverse of a function can exist. Right, so for an inverse of a function to exist, it has to pass, that function has to pass a vertical line test and a horizontal line test, right? So that is the case. And another thing is that how do you find the inverse of a function? First of all, you make x as the subject, and then you replace x with y and y with x. This is how you find the inverse of a function. So let's just go ahead and solve some questions related to the inverse of a function. So I have this question here. So this question here says that define f by the equation this. Given that this function has a well-defined inverse, determine the value of this. So what I have to do is I have to determine the value. So first of all, f of x is equal to x cubed plus x minus 4 is equal to y, right? So this is what I have to do. I have to get the value of f of x is equal to x cubed plus x minus 4 is equal to y. So we have to find f inverse of negative 2. So if you kind of go back to what I discussed, I said inverse is f inverse of y is equal to x, isn't it? So your value of y should be negative 2, which is here, and your value of x is something that you need to find, right? So that means x cubed plus x minus 4 should actually be equal to negative 2. And this value of x, because it's kind of, it doesn't make, you can't, it will be difficult for you to make x as the subject right away. So it'll be better that if you substitute numbers initially. So what I did here is, that's one way of doing this is, when someone asks you f inverse of minus 2, you substitute y as minus 2, and x will actually give you what the question is asking you, right? So that is what we want. So this over here is, we just need to solve this equation up here now. So this is x cubed plus x minus 4 plus 2 is 0, which is x cubed plus x plus 2 is equal to 0. This is nothing but I think x minus 1 whole cube, because if you kind of open this up, it's a cube plus no, that's not what it is. Okay, let me just solve this up. I think if I just see this thing here, I can clearly see that x is equal to 1 is something that satisfies this equation. Understand, you're always going to have 4 answer options here, right? So one of them is going to be 1. So 1 cube plus 1 sorry, this is negative 2. Minus 2 is actually equal to 0. So, 2 minus 2 is 0. So 1 is something that satisfies this equation. Another way of solving this is you can say x cubed plus x is equal to 2. Then you say x, you take the x out, you say x squared plus 1 is equal to 2. Right, now you just see what all values can satisfy. 0 will not. 1 is something which will satisfy. That means 1 is the answer. So x is equal to 1 is actually the answer. So I hope you got this, guys. I hope you understood this. We're going to be solving more questions, especially for every topic. We're going to be solving questions. Right now, my strategy is that you understand the concept. That is more important. And then we go on to the questions, and then we just stay in the questions, trying to learn what all things does the test is going to ask you, right? So that's there. So first of all, it's very important that you understand the basics. Okay, now let's see this question here. So this question says that let A be an open interval and define a bijective function f on A by the equation. So this is the function. Find the formula of f inverse of x. So this is actually equal to y. So how do you find the formula for f inverse of x? So what you do is you make x as the subject. That is what you do. So let me just write that down here. So y is equal to x over 1 minus x squared. Let's just make x as the subject. So I'm going to take this to that side. So you're going to have y into 1 minus x squared is equal to x. Then you have y minus x squared y is equal to x. Then you have, I'm going to take everything on that side. So I have x squared y plus x minus y is equal to 0. Now what do I have? I have a quadratic equation. How do you find the roots of the quadratic equation? Well, the formula is minus b plus minus square root b square minus 4ac divided by 2a. This is how you find the roots of the equation, different values of x, two different values of x. So here your value of a is equal to y because you have y here. The value of b is equal to 1 because you have 1 here. And the value of c is equal to negative 1 because you have negative 1 here. So these are the values you have. Let's substitute minus b, that is minus 1, plus minus square root b square minus 4 into a. I'm sorry, this is minus y. The value of c is minus y because that's the whole value of c, right? B square minus 4 into a into c divided by 2 times a. That is equal to x, right? So that means x is equal to minus 1 plus or minus square root 1 minus, and minus makes it plus 4y square divided by 2 times y. Now the next step is to replace y with x. So instead of x, I'm going to write y, that is equal to minus 1 plus or minus square root 1 plus 4x square divided by 2x. This over here is the function, which is the inverse of this particular function. Right, so that is that. Remember, if the question was asking me f inverse of so the question here is asking us the f inverse of x, right? So that means the question is asking us the inverse of this function. Now this can actually be further explored because x can actually take different values. It can take negative values as well, and this can take positive values as well, right? So this can be a different function when x is negative, and this can be a different function when x is positive, right? So because if x is negative, then this thing will change, it'll become negative. When x is positive, this thing will change and it'll become positive. And there's another problem that you see that you're encountering here. The problem is that 0 is part of your range here, right? 0 is part of your range, but 0 is not part of your range here because x cannot be 0. So that means we need to further simplify this function in order to get anything out of it, right? So our function is y is equal to, so our function is y is equal to negative 1 plus or minus square root 1 plus 4x square divided by 2x. Now what I'm going to do is I'm going to write 2x as, so I'm going to cut 2x, I'm going to write 2x as square root of 4x square. Gives you the same thing, isn't it? But we will put positive and negative wherever we want to, but right now let's just say plus or minus square root of 4x squared. That is what I'm going to write because I need to show you something here. Now what do I need to do is, first of all, I need to break this plus and minus barrier. So how am I going to do that? Now let's say you have negative here, right? So let's say we talk about the negative scenario. If I talk about the negative scenario, this becomes y is equal to -1 negative something. So I have negative something, that is negative 1 plus 4x squared, divided by negative of, again, if x is negative, 2x is actually going to be negative, as we've said. When I say x is negative, right, so 2x is going to be negative. Negative of something. Now again, understand 1 plus 4x squared will always be greater than 4x squared, no matter what, square root 4x squared, right? 1 plus 4x squared will always be greater than absolute of 4x squared, because that's how it works. 1 when added to a number will make it greater. So that means this is something which is it's a smaller quantity than something, right? So it's a smaller quantity in something. You can clearly see that this value over here, it's going to go, so you have negative here, you have negative here, you have negative here, that'll make the whole thing positive. This value is going to go greater than 1 all the time, isn't it? This value is going to go greater than 1 all the time. On the other hand, if I take x to be positive, if I say x is positive, then y is equal to -1 plus something, the same thing, but it's going to have, so you're taking, I'm actually taking not the positive one, I'm actually taking x greater than 0, but still the negative case. So it's going to be minus something. I'm still taking the negative case, but I'm saying when x is greater than 0. That's what I'm saying. I'm still taking the negative case, but I'm saying when x is greater than 0. Then you're going to have -1 negative something, the same thing, but in the denominator, you're going to have positive but smaller. So you can clearly see that this will go less than -1, because this will always be greater than this value, and this division will always go less than -1. It'll go -2, -3, it can go wherever, but it'll go less than -1, and it will not fall in this range. Sorry, it will not fall in this, in this range. Right, so that means we can disregard the negative value and we can only take the positive value. Right, so we can disregard the negative value and we can only take the positive value, which is 1 plus 4x squared divided by 2x. Now just to get rid of this 2x, what you can do is you can actually rationalize this. That's up to you. You can rationalize this. So how do you rationalize it? Instead of having -1 and positive here, you're going to have -1 and negative 1 plus 4x squared, and you have -1 and -1 plus 4x squared. Right, so this is what you can have. You can rationalize it. It'll come up. So you will have a function here which will actually be your answer. So I hope you're getting what I'm saying here, right? So this question was a piece of work. But at the end of the day, you got to learn a lot of things. First thing you got to learn is how do you find the inverse of a function. Second thing, when you're finding the inverse of a function, just check that all the values. So if you have some values in the range here, the same values should work in the range here. So 0 was part of the range here as well as the domain here. So 0 should be part of the function here as well, because that's how an inverse works. An inverse will map all the possible values which are there in the actual function, right? So it will not leave any value behind. Otherwise, that inverse will not exist, right? So if just this function was there in the answer option with a negative, then that will not be the answer. You'll actually have to find the bigger function. And again, when we are solving with answer options, it takes less time, it takes less effort. But right now, my purpose here is content rather than strategies. We're going to be going to strategies. There's no problem there. But right now, my purpose is content. So I hope you understood what I was explaining here, guys. Thank you very much for watching this video. And I hope it really helped you out. And I'll see you in the next one.